The lesson from Monday has been recorded and is uploaded on YouTube. You just have to look up the name of the lesson. You put in IM3 lesson and then whatever lesson you're looking for. I'm only going to be recording up until Unit 3. After Unit 3, everything is online. I've already recorded that from last year, so you can watch those videos. Today, we're going to be talking about function operations and composition of functions. By the end of this lesson, you guys will be able to perform operations on functions, evaluate composite functions, as evidenced by completing a whiteboard drill, a team task, and a closure task. Let's begin with the warm-up. I'm going to give you and your teams the next 6 minutes to complete problems A through F. You're answering these questions relevant to functions g of x and h of x. So you have 6 minutes starting now. Okay, let me get your attention over here, please. So we're going to go over the warm-up now. Most of you guys were able to complete all of it, so that's very good. Let's take a look at what we got as our answers. So if we want to evaluate g of 3, that means that we are plugging in 3 in place of x. So what is g of 3 going to equal, Sebastian? G of 3, what is g of 3 going to equal? 12. Very good. All right, moving on to h of 3. What is the setup for h of 3? How am I going to write my setup for h of 3? Can I hear from Kieran? H of 3. Excellent. Thank you very much. All right. So what do we get? H of 3 is going to equal how much? Jesús. No, tú es Chuyín, ¿no? Jesús va a ser Jesús. 2 times 3 is 6. 6 minus 1 is 5. Very good. So 6 minus 1 is equal to 5. H of 3 is equal to 5. How are we doing so far? We got these correct? All right. So on the quiz Friday, you're going to see questions like these. You better get them right because they're easy. Okay, for part D, we're going to add the results from part A and B, or in other words, what is g of 3 plus h of 3? So I want everyone to rewrite this, g of 3 plus h of 3, in case you haven't done it, because we're going to replace what g of 3 is and what h of 3 is also equal to, which are, the results we found earlier. We said g of 3 is equal to 12, and h of 3 is equal to 5. So this is going to equal what? What's 12 plus 5? 17, right? So we're saying g of 3 plus h of 3 is 17. By the way, these two are the same thing. I'm just writing one on top of the other. I'm not doing it to make you confused. I'm just rewriting it for notation's sake. They are the same thing. G of 3 plus h of 3 is 17. G of 3 is 12. H of 3 is 5. That's how we get 17. Okay? Doing good so far? All right. Then we move on to D, and a lot of people are asking me about D. They're like, what does this mean? Because we don't have a specific input, our input is in terms of x, then you're going to leave the equations how they are, meaning you're not going to change the x's with anything. So if we are introducing a new function, k of x, that is the sum of g of x plus h of x, then we're going to replace g of x with its respective equation and h of x with its respective equation. So we're going to get something like this. G of x is 4x. H of x is 2x minus 1. All right? Right, once again, g of x is 4x. H of x is 2x minus 1. Matter of fact, I'm going to place parentheses just so you guys know which one is which. Does that help? Okay. We have to put everything together. We have to combine like terms. So when we combine the x's, what do we get? Maddie, when we combine the x's, what do we get? 6x, and then we have a minus 1 left over. This will be our new equation, 6x minus 1. Let me move this sideways so we have more space to work with. All right. So let's evaluate k of 3. K of 3, that's 6 times 3 minus 1. What do we get? Grace, what do we get? 18 minus 1 is 17. So k of 3 is 17. Excellent. Any questions so far? All right. Now, I'll take volunteers for this last one. What do we notice about the answer for part C, where we got 17, and part E, where we also got 17? What do we notice? They're the same answer. But is the process the same? No. In this part, we are adding the outputs. In this part, we added the equations and then found the output. So let's write something along the lines of the following. So Bowman said they are the same answer. Yes, that's correct. They are the same answer. But part C, how do we want to phrase this? Gives you the added added outputs, and part E adds the functions first. Okay. So that's just to say that in part C, you're like evaluating first individually and then adding everything together. In the other section, in part E, you're adding everything together first and then evaluating. Okay, so we're like switching the order. However, you'll notice that we get the same result. Okay. All right. You guys can finish typing that up, and we're going to move on to some guided notes. Are there any questions on the warm up before we move on? Is everyone doing okay? Yes. Okay. All right. In that case, let's jump to the next section with some guided notes. All right. So it says here, as you noticed in the warm-up exercises, you can substitute the input into each function first and then add the two outputs together. That's kind of what I said earlier, right? You can substitute the input into each function first and then add the outputs together. Or you can add the functions together and then plug in your input, and you will get the same result. This notation, or the notation, used to evaluate the sum of two functions in part C of the warm-up is, you're going to write this down, the following. We're going to write it like this. Let me type it out so it looks better. Where's my mouse? There it is. There it is. Hold on, where's my pen? Here it is. G plus H of 3. So you write this down, G plus H of 3. Now, G plus H of 3 is the same as G of 3 plus H of 3. And this is just kind of summarizing what we did in part C. In part D, you added two functions to create a third function, and the notation for that is the following. We did g plus h of x, which we found was the same as adding g of x plus h of x. So essentially, when we add two functions, you can write it two separate ways. You can do it as adding the functions first and then solving for an input, or you can write it as solving each function independently and adding the outputs. They are the same thing. Now, if this is what adding looks like, what do you think subtracting will look like? What am I going to change? If it's subtracting, what am I going to change? I'm just going to change the plus sign. Instead of a plus sign, I'll have a minus sign. So g minus h of x. And what do you think that's going to equal? G of x minus h of x. Very good. Go ahead and try finding g minus h of 3. You don't have to solve anything new. You already have the outputs from parts A and B. So what I want you to write is the following. I want you to rewrite g minus h of 3 in this format. But instead of x, what are you going to write? 3. Take about 30 seconds for that. Right, so you should have the following. G of 3 minus h of 3. And we found g of 3 was 12. And h of 3 was 5. It's going to be 12 minus 5, which is equal to 7. Thumbs up if you got 7. Cool. Okay. So we know what adding and subtracting looks like. What do we think multiplying will look like? How am I going to write multiplication? Let me hear from one of you guys. Double. How are we going to write multiplication? What am I going to change? What am I going to put in here if it's multiplying? The multiplication sign, which is a dot. So g times h of x. What is g times h of x the same as? At least. How can I rewrite g times h of x? At least. Based on what we've done so far, how can I rewrite this? Good. G of x times h of x. Let's try to solve an example. G times h of 3. G times h of 3. G times h of 3 is the same as g of what? G of what? Lorena, what am I going to put in the parentheses? G of 3 times h of 3. Again. That is 12 times 5 or 60. Okay. Dividing we're not going to see, so don't stress about that. Okay. Any questions so far on the notation? All right. Next page. Okay. So there will be times when operations on functions will remain in terms of x, meaning there will be times where you will not have an input. So how can you solve something? How can you combine if you don't have an input? Let's consider the functions f of x and j of x, and we're going to find the following. In part A, suppose we want to find the difference f minus j of x. Well, let's use our notation. F minus j of x is the same as what? Based on our notes, f minus j of x is the same as what? F of x minus j of x. Okay. We are going to replace the equation that f of x is equal to and the equation that j of x is equal to as well. So we'll have the following. F of x is x squared minus 3x plus 2. And we are subtracting j of x, which is 5x minus 4. Please place parentheses around these like I did. Because we're subtracting one function from the other, the parentheses are essential. Otherwise, you will not get this correct. Because you have to distribute the negative. This minus here in front of 5x and negative 4, this minus has to be distributed to both terms. Okay? So go ahead and write that down. If I am distributing a negative, what am I going to get? Let's start with the first function. So that's x squared minus 3x plus 2. That doesn't change. What does this become? First term, 5x. Is that going to stay as 5x? What's it going to become? Negative 5x. Very good. So we have negative 5x. What about negative 4? If I multiply negative 4 with a negative 1, does it stay as negative 4? No. What does it become? Positive. Why? Because a negative times a negative makes a positive. We are going to combine like terms at this point. So we're going to combine negative 3x and negative 5x as well as 2 and 4. There is nothing else to combine x squared with, so that's going to stay as it is. We are going to get our final solution of x squared minus 8x plus 6. Yep. I have 30. All right, any questions so far on this example, part A? So that is subtracting. Let's take a look at what it looks like when we add the terms together. What is f plus j of x? F plus j of x is the same as what? How am I going to rewrite f plus j of x? What did we see from our definition earlier? Go ahead, sir. It is f of x plus j of x. So we're starting to see some patterns here, right? Hopefully. F of x plus j of x. Just like we did in part A, we replace f of x with its function. We replace j of x with its function, and we combine like terms. F of x becomes x squared minus 3x plus 2. We're going to add 5x minus 4. If you wanted to distribute a positive 1, you could. It's not going to change any of the signs here. So we're going to kind of skip that step. We can go straight to just combining like terms. We combine negative 3x and 5x, and we can combine positive 2 and negative 4. x squared plus 2x minus 2. This is your new solution. X squared plus 2x minus 2. Okay. I'm going to show you one last example, and then we're going to do a whiteboard drill. So I'm going to talk to you guys for just a few more minutes, and we'll move on. All right, final example. What happens then if we want to multiply these functions together? F times j of x. Well, why don't we begin by writing what f times j of x is equal to. We should kind of know by now because we've seen two other examples and the notation has not changed. What is f times j of x equal to? Say that again. F of x times j of x. Excellent. F of x times j of x. Okay. I do have to warn you, it's going to get messy. So let's check in. So f of x is x squared minus 3x plus 2. And we have 5x plus 4, sorry. 5x plus 4. Minus 1. Whoops. Okay. Because we are multiplying these terms together, we could do it one of two ways. We could use an area model or a distributive property. But the best way to do it between those two is definitely an area model. Now, because we're multiplying 3 terms by 2 terms, we're going to make an area model that has 3 columns and 2 rows. 3 columns and 2 rows. The 3 columns correspond to f of x, which will be x squared minus 3x plus 2. And the 2 rows will correspond to 5x minus 4. Do we know how to use an area model, guys? I'm going to remind you with maybe like just 2 operations, and then I want you to do the rest, okay? So the way an area model works is multiplying the numbers on the outsides. So for example, top left box, we're multiplying 5x and x squared together. So that's going to give you 5x to the 3rd power. To get the bottom box right here, that's negative 4 and x squared. You multiply those together. All right. Let me give you about 2 minutes to solve the area model. Okay. So let's fill out the box, which hopefully you already did. I want you guys to give me the following. What goes in this box right here? Whoops. Let me zoom in. What goes in this box here? Let me hear from Kenneth. What goes in this box right here? Menos 15 x squared. What goes below negative 15x squared? Let's see, recall and Grace. Let me hear from Brian. What goes down here? 12x squared. What are we going to put here? Maya, what goes here? Oh, it's not squared. Oh, sorry, that's right. Not squared. Whoa. Okay, hold on. Negative 15x squared, and you said this was 12x. All right, Maya, go ahead. What goes over? 10x. And then what goes underneath 10x, Alexandra? Negative 8. What is the final answer going to be? Pregunta. Okay. Final answer? Yuvia, you have it? No? Question? You're good? Okay. Final answer? Yes. Go ahead.
I got 5x cubed minus plus 22x minus 8.
Give me a thumbs up if you got this same solution. All right. Very good. That is correct. Okay. Next task is going to be a partner task. So find a partner, and if it's a group of 3, I'll place you with somebody else. Yeah, you have a partner. All right. Once you know who your partner is going to be, come up here, grab a whiteboard, grab a marker, and have a seat. All right. Let's continue with our work here. So we're gonna do a little bit more guided notes. Function composition. So let's talk about what that means. Today's team activity will involve the next 4 functions. We have f of x, which is the square root of x. I'm gonna rewrite it just in case you can't see it. Square root of x. We have g of x, which is negative x minus 2 squared. Negative x minus 2 squared. H of x, which is 2 to the power of x minus 7. And we have k of x, which is negative x over 2 minus 1. First one is the square root of x. Okay. Let's find the following 4 inputs. Let's start with A. What is the value of f of 4? So let's rewrite this. F of 4 means the following. F of 4 means we want to find the square root of 4. What is the square root of 4? We're looking for a number times itself that gets you 4. That number is 2. The square root of 4 is 2. All right. We're good so far. G of 2. If we want to find g of 2, then that means we want to plug in 2 in place of x. That is negative parentheses 2 minus 2 to the second power. Well, it turns out that 2 minus 2 is what? 0. And anything times 0 will be 0. So we're going to find that g of 2 is actually equal to 0. Yep. H of 0 is 2 to the 0 power plus minus 7. Sorry, minus 7. Maybe you remember this from IM1, but the 0 exponent property tells you that anything to the 0 power is going to equal what? Not 0, not 2, but 1. 1. So that is 1 minus 7, which is equal to negative 6. Okay. What is k of negative 6? K of negative 6, we're plugging in negative 6 into the following. Negative 6 over 2 minus 1. Once again, negative 6 over 2 minus 1. All right. What is half of 6? Half of 6 is 3. In this case, make it negative. Negative 3 minus 1 is negative 4. Okay. Hold on. Did I do that right? Yes. Unless I did a typo here. Oh, wait. I did it wrong. Whoa. What the hell? Oh, man. Okay, we were right here, right? Yes. So here's the problem, though. And this is what I did wrong. So we have negative x over 2 minus 1. But when you plug in a negative 6, you have negative 6 over 2 minus 1. So we have a case of a double negative. Negative 6 becomes positive 6 over 2, which is 3. So this is 3 minus 1, which is equal to 2. Yep. So that's what we're actually looking at. Positive 2. All right. So let's move on down here. And for some reason, I lost the rest of the notes. I don't know why they're not there anymore. Okay, so function machines can be stacked so that the output of one function becomes the input for the next function. For example, imagine the functions are stacked in order and 4 is inputted into the first machine. When we plugged in a 4 into F, what was the output? You guys should have that. What was the output? 2. So 4 goes into F, we get a 2. And then what did we plug into G? Look at your work. We did G of what? G of 2. So we took that 2 and we plugged it into G. G of 2 gave us what answer? 0. And then in part C, we evaluated H of 0. And that gave us negative 6. Negative 6 went into K. That was the final thing we did. What was the final answer? 2. Okay. So we started with the 4 and we finished with the 2. Now, question, yes. She's going to go first. You can go after her. Okay. So to summarize, this is how function composition works. You take a number and you plug it into one function. You take a number and you plug it into one function and it gives you an output. You then take that output and you put it into the next function. That output, put it into the next function. And then you repeat it. All right, until you get your final solution. That is the overview or the general grasp of what function composition is. All right, you have a team activity down here, which says, in what order should you stack the machines? Remember, the machines are F, G, H, and K, so that you get, with an input of 6, a final answer of 11. You are going to have 10 minutes to figure this out. And you can use calculators. This is a team task, which means you're working together as a group. If you're not sitting with your team, please go back to your seats and sit with your team so that you can finish this work. All right. You have 10 minutes. Send somebody to grab a calculator, and you guys can begin. Looking up at the screen. We start with the 6. I gave you the first one. I said the first one was G. When you plug in 6 into function G, you get an output of what? Positive or negative 16? Negative 16. Negative 16 goes into which function next? H or K? Negative 16 goes into K. And when you plug in negative 16 into K, you get an output of 7. 7 goes into H to give you 121. 121 goes into F to give you a final solution of 11. Okay, that was a challenging problem. If you didn't get it, it's okay. All right, we have about 15 minutes left of class, so I'm going to kind of rush through the rest of these. The bonus question you can do at home for fun. If you find yourself bored over the weekend, you may do it. So let's talk about the terminology of what we just did. So what we just did with the function stacking is called composition of functions. And function composition happens when you take an output of one function and you input it into the other. All right, are we all paying attention? I hear people talking, and this is an important topic. Once again, taking the output of one function and plugging it into the next, that is what we call function composition. So this is how we can rewrite what we just did in that team task. We started with a 6. You guys should be writing this down in your notes. We started with a 6, and we plugged 6 into function g. Plugging in 6 into function g is the same as doing g of 6, right? Because we plugged in 6 into g, gives us g of 6. Well, g of 6 we said was negative 16. Negative 16, we plugged it into k. Plugging in negative 16 into k is the same as finding k of negative 16, where 16 is our input. Additionally, we could write this, instead of k of negative 16, we could also write this as k of g of 6, where g of 6 is the input of k. Numerically, though, our answer was a 7. So we're doing layers now. Think of an onion. You see how an onion has layers? We're doing the same thing here. G of 6 is the input for k. K of g of 6. 7 goes into function h. So we are doing h of 7, right? Or you could think of this as h of k of negative 16. Or if we were to think back to the first one, this would then be h of k of g of 6. All three of these are the same. They're the same thing. We're just doing layers. Okay? Numerically, that was 121. What do you think the last one's going to look like? Okay. Well, numerically, the answer, yes. The answer is 11. But if we're thinking about function notation, then it would be f of h of k of g of what number? What was the number we started with? 6. F of h of k of g of 6. Relevant to the first part that we did, which was g of 6. All right, so it's pretty crazy, yeah. But like I said, it's like an onion. There's layers, right? The outside is made up of the inside of the onion. I don't know if that makes sense. Anyway. So let's look at the example with the Oreos. How many of you guys like Oreos? Everybody likes Oreos. If you don't like Oreos, you're weird. F of x Think of f of x as the shell of the cookie, right? The black part of the cookie. And think of g of x, gentlemen, think of g of x as the cream on the inside. F of g of x means f on the outside, g on the inside. It's a regular cookie. G of f of x is an inverted cookie. Cream on the outside, cookie on the inside. Kind of weird. But it helps kind of bridge that visual representation between the function and what they represent. Okay? All right. The notation for function composition then is the following. By the way, you will not see it like this on a quiz or on a test, so don't stress about this. But mathematically, you would regularly see it as this. FOG, like fog, FOG of x. And this notation here you won't see on a quiz or on a test. But this one here you will. So f of g of x. Like this, you will definitely see that. So you should be good with this notation. F of g of x. Okay. Are we all okay with the notation? I'm going to show you one last example, and that'll be it for today, okay? All right. Okay. Let me get your attention for about 3 to 4 more minutes while I finish this up. Consider the functions g of x and f of x. What is g of f of 2? Let's ignore this notation. Like I said, I don't like this, and you probably won't see it either. We want to find g of f of 2. Rewrite it like that, g of f of 2. When you see this notation, you are starting from the inside and working your way outside, which means evaluate f of 2 first. Whatever you get, then you can plug that into g. That's what this is saying. It's saying find f of 2, whatever you get, plug it into g. So, for your final task today, find f of 2 and then plug that answer into g. You have 6 minutes to do that. We'll check in, actually make that 5 minutes. We'll check in 5 minutes. Go ahead and begin and work with your team.